Hello, and we're reviewing Chapter 6 in the Lock 5 Statistics textbook. In this video, we're going to look at example number 3. Suppose 65 college students were asked to track their sleep time each night over a month, and then give an average for their sleep times. And that data is in a CSV file, Excel file titled Sleep Times on Canvas. So that should be in the Chapter 6 module. Doctors are concerned that college students likely get less than the recommended 8 hours of sleep each night. So we use proper notation for these questions. So what is the population parameter? So we're looking at an average or mean. So for population parameter, we use the character mu. And we're going to say this is the average sleep per night for a college student. So these researchers want to know, well, what on average, how much sleep does the average college student get? Or how many average hours of sleep per night? I should say hours of sleep per night for a college student. Okay, and now I want to compute the sample mean and sample standard deviation. So I'm going to open up that spreadsheet right here. I've got sleep times and hours. And there's multiple ways to do this in StatKey. What I'm going to do is I'm just going to highlight all of this data. Control C or Command C. I need to go to StatKey. All right, go to the main page in StatKey. And I just need to compute some statistics, some descriptive statistics. So I'm going to go to one quantitative variable because we're looking at an average hours of sleep per night. I'm going to click on the Edit Data, Control A, Command A, delete all of this, unclick all of the header, copy and paste, upload all the data on here, and click OK. And just to make sure this makes sense, we have a sample size of 65, which is what we're given, and the average of these 65 college students over the month is 6.668 hours, with a standard deviation of 0.772. So I need to write this information down using proper notation. The X bar, the average mean, is 6.668 hours. The standard deviation, we're going to use lowercase s, is 0.772. And the standard deviation would also be in hours. And I'll note the sample size here is 65. So we've got our summary statistics here from this sample mean. Going down, we use the Z or the T distribution in order to compute a 98% confidence interval. All right, so I want to note here we only, I'm going to put that in caps, know the sample data. So in this case, we're always, in this class, going to always use, so we use the T distribution. So I should add something else here. We only know the sample data, and we are looking at a mean. So those two, if we're looking at a mean or average, and we only know sample data, that's when we use the T distribution. And I want to reference the formula sheet that I passed out. Looking right here, we're looking at a single mean. And my note right here, the sigma, that's population standard deviation, that's unknown. So if it's unknown, we're going to use T star and T. All right, and I think the next question on here is actually to compute a 98% confidence interval. So I'm going to rewrite that formula. It's X bar plus or minus T star times standard error. All right, so here's the formula. And we know what X bar is. And we need to figure out T star and the standard error. So let's go back a little bit. That's the formula we need to use. Before we can use that formula, we need to figure out standard error. And And that's going to be right here. Standard error is approximately, via central limit theorem, the sample standard deviation divided by the square root of n. So in this case, it's the 0.772 divided by the square root of 65. And if I throw that in the calculator, 0.772 divided by the square root of 65, we get 0.09575. So 958. We round to 4 decimals. And if I want to figure out T star for a 98% confidence interval, I need to go into stat key to figure this out. And then don't forget with T, we're going to need the degrees of freedom. So I've got a sample size of 65. So I'm going to go back here, go to the T distribution. Degrees of freedom is 65 minus 1. 64 degrees of freedom. And that is also given on your formula sheet. Degrees of freedom is n minus 1. And I'm looking for the 98% confidence interval. So I'm going to click on the middle, change that to a 0.98. And I could pick either of these two cutoffs, but I'll pick the positive 2.386. So 2.386. So putting this all together, we get the confidence interval is 6.668 plus or minus 2.386 times the standard error, 0.0958. So I'm going to compute that and give an interpretation. We are 98% confident that the average college student sleeps somewhere between, I'm going to throw this in the calculator, 6.668 minus 2.386 times 0.0958, and that gives me 6.44. And then I just need to go back and change the minus to a plus. 6.90 hours of sleep per night. So that is the confidence interval. And I now want to run a hypothesis test. But before we do that, just notice the researchers want to know if students get less than 8 hours of sleep, at least according to this confidence interval, and it's not looking like students are getting 8 hours of sleep. But let's run through this. So here I want to state the null and alternative hypothesis, defining parameters when necessary. So notice in this case we've already defined the parameter up in here in part A, this mu. So I don't need to define it again. I'm going to just write h sub 0. The null is mu equals 8. We're going to assume that college students do get 8 hours of sleep. But the evidence and what these researchers think is that they're getting less than 8 hours of sleep. Determine the value of the observed sample statistic. All right, so the test statistic is T. So I'm going to go back here to that formula sheet. My test statistic is T equals x bar minus mu over the standard error, which we've already computed. So I'll write it out. This is minus mu over standard error. So that's going to equal x bar, which we have up here, 6.668 minus 8, all divided by 0.0958. Using this value from above, the standard error is the same. And I'm going to throw that in my calculator, 6.668 minus 8, divide that by 0.0958, and we have minus 13.9. All right, so I need to find the p-value, but this is, let me just put this, this is almost 14 standard deviations away from the middle. That is highly, highly, highly unlikely. Remember that 95% of data is within 2 standard deviations. So just to point that out, I do want to compute the p-value and then decide. To do that, I need to go to stat key, click the center. We are looking at a normal distribution, t distribution. Degrees of freedom are 64, 65 minus 1. Click OK. And we're doing a left tail because it's a less than as our alternative hypothesis. At the bottom, I'm going to write down minus 13.9. And this is going to be a very extreme. Notice how far we are from the center of 0. We get a p-value of statistically 0. So the p-value is statistically 0, which is less than significance of 0.02. Just a note, we use a significance alpha, 0.02. And the reason why we use an alpha of 0.02 because confidence level is 98%. Significance and confidence always have to add up to 1 or 100%. But either way, p-value is statistically 0. So we are going to reject the null hypothesis. This study provides fairly strong evidence that college students sleep less than 8 hours per night on average. All right, that completes the hypothesis test. Just one last note, the hypothesis test was reject the null that college students sleep for 8 hours and support the alternative, and so does the confidence interval. The confidence interval does not contain 8, doesn't even get fairly close to 8. So this is a good evidence that, at least with these 65 college students, this was a good sample. College students get less than 8 hours of sleep